Hi guys, hope everyone's doing good. Hope you're staying home and staying safe. So for today's lecture, we will be having a discussion on model analysis. Basically, it's either done on a cast or on a radiograph. So we shall go into the details in the coming slides. These will be your learning outcomes. So at the end of the lecture, you should be able to define and describe the advantages and disadvantages of model analysis, describe the methods used to do model analysis, and also detect space discrepancy using model analysis. A brief introduction. Model analysis is one of the essential diagnostic aids. It is used to determine the difference between the space available and the space required for tooth alignment. So basically, it helps in the determination of space discrepancies in any of the arches and also aids in the decision to opt for either arch expansion or extraction. All right. So for performing a model analysis, you will require well-prepared study models, vernier calipers or a divider, a ruler, and some brass wire. So what are the different types of model analysis? So I've divided them into three groups or three categories. Category one will be analysis used to assess the need for extraction. So here it's further divided into maxillary arch, which is the arch perimeter analysis, and mandibular arch, Nance Carey's analysis. Analysis used to assess the need for arch expansion, which is actually Howe, PONT'S, LINDER, Korkhaus analysis, and Bolton's. And then finally, the third category of mixed dentition analysis, which is Moyer's, Tanaka and Johnston, Nance, and the radiographic method. So the first analysis we'll be discussing about is the arch perimeter analysis, which is usually done on the maxillary arch. Here, two different measurements are required. One is the calculation of space available, and the other one is calculation of space required. So how do you calculate the amount of space available? So what you will do here is you will take the brass wire and pass it from the mesiobuccal line angle of the maxillary right first molar all along the buccal cusps and the incisal edges of the anterior teeth to the left quadrant until the mesiobuccal line angle of the left maxillary first molar. All right, that is starting from the mesiobuccal line angle of 1 6 to mesiobuccal line angle of 2 6. Here are some variations on how you will pass the brass wire on the anterior teeth. In case of retroclined incisors, you will pass the wire labial to them in a smooth curve-like fashion. Whereas if the teeth are proclined, then you will pass the wire palatally in the cingulum region. So for step 2 of the arch perimeter analysis, you will calculate the amount of space required, and you will do so by measuring the mesiodistal dimension of all the teeth mesial to the first molar, that is 5 to 5. So you will measure the mesiodistal dimension of all these teeth and then sum them up. So how do you interpret the arch perimeter analysis? So after you have calculated the amount of space available and also the amount of space required, if you find the difference between these two measures, you will be able to know if there is a deficiency in space or there is excess of space. So if the tooth material is more than the arch length, okay, this will indicate that the space available for alignment is insufficient, resulting in crowding. On the other hand, if the tooth material is less than the arch length, then you can understand that there will be spacing. So the table here shows the arch length discrepancy versus the inference. So if there is a discrepancy of 0 to 2.5 millimeters, how do you treat that, or what exactly do you need to do to gain that space? So you can perform proximal stripping so that you reduce the tooth material. If the discrepancy is 2.5 to 5 millimeters, extraction of second premolar is indicated. A discrepancy of greater than 5 millimeter, you will have to consider extracting first premolar um, to gain that much of space. Now coming to the second analysis, which is Nance-Carey's analysis, the difference between arch perimeter analysis and this analysis is uh, just that arch perimeter is performed on a maxillary arch, whereas Nance-Carey's is performed on a mandibular arch. So how do you perform a Nance-Carey's analysis? So step one is to determine the arch length, that is the total space available. So here what you will do is you will pass the brass wire from 4/6, that is the mesiobuccal line angle of mandibular right first molar, or 4/6, to the mesiobuccal line angle of left mandibular first molar, that is 3/6. So again, you will do the same process. You will mark the wire, you will straighten it, and then measure the wire to give you the space available. So as we did it for arch perimeter analysis, in case of proclined incisor, you will pass the brass wire in the cingulum region, whereas for retroclined incisor, you will pass the wire labially. So continuing the procedure of Nance-Carey's analysis, step 2 will involve the determination of tooth material. Here you will measure the mesiodistal dimension of all the teeth mesial to the first molar and add their values. That is from 4/5 all the way up to 3/5. You will add the mesiodistal dimensions of each of these teeth, and then you get a value, and this value will give you the total space required. Step 3 will be the determination of the discrepancy. So whatever you've calculated in the total space available, and you have to find the difference between that with total space required. So this difference will give you the discrepancy in the arch length and tooth material. So how do you read the discrepancy? So anything between 0 and 2.5 millimeters, as in arch perimeter analysis, is the same inference here as well. You will perform proximal stripping. So anything between 2.5 and 5 millimeters, you can consider extracting second premolar, and you can consider extracting first premolar if you see a discrepancy of over 5 millimeters. The third analysis we'll be discussing is Ashley-Howe analysis. It is usually done on the maxillary arch. Howe considered the crowding of teeth to be the result of deficiency in arch width rather than the arch length. So in arch perimeter analysis and Nance-Carey's analysis, we were talking about the discrepancy in the arch length. But here it is it centers around arch width rather than arch length. So Howe found the relationship to exist between the total width of mesiodistal distance of teeth anterior to the permanent second molars and the width of the dental arch in first premolar region. This you will be able to see in the next slide on an image. So how do you perform a Ashley-Howe analysis? So basically there are three different measures. So you have to first determine the tooth material. For this, you will measure the mesiodistal width of all the teeth anterior to the permanent second molars, and then you will sum them up. And for the determination of the premolar distance or diameter, you will measure the distance or the arch width from the tip of the buccal cusp of the first premolar to the tip of the buccal cusp of the opposite first premolar. Following this, here you will determine the premolar basal arch width. You can see two arrows on the image on the right hand side. Basically, you are finding the distance between the uh, distance or the width between the canine fossa on either side. So this width will actually give you the width of the dental arch at the apical base, or the junction between the basal bone and the alveolar process. So in Ashley Howe, basically you have uh, determined three different measures. The first one was tooth material, the second one was uh, premolar width, and the third is the premolar basal arch width. So what is the inference you are able to gather from Ashley-Howe analysis? So there are basically two inferences which can be derived. Inference one is the comparison of PMBAW and PMD, that is premolar basal arch width and premolar distance. So basically, if PMBAW is more than PMD, then you can say that arch expansion is possible. If, on the other hand, PMBAW is less than PMD, arch expansion is not possible. So inference 2 is the relationship between PMBAW and the tooth material. So for a normal occlusion with a full complement of teeth, PMBAW should be 44% of TTM or tooth material. Okay, so the distance or the width between the two canine fossa should be 44% of the tooth material. So there is something called uh, percentage analysis wherein you're calculating the BAW times 100 divided by the tooth material, which will give you the percentage ratio. So if the percentage is around 37% or lesser, you can deduce that there is need for extraction. If it is anywhere between 37 to 44%, it's a borderline case or a non-extraction case. And if it is more than 44%, possibly non-extraction if other local factors are favorable. Now coming to the fourth analysis, which is known as PONT'S index. So PONT in 1909 proposed a method of determining the ideal dental arch width in premolar and first molar area based on the sum total of upper maxillary incisors. So basically this analysis helps in determining whether the dental arch is narrow or is normal in the premolar and molar region for a given sum of incisors. Also helps in determining the need for lateral arch expansion, and finally to determine whether the expansion is possible or not at the premolar and molar regions. So how do you perform a Points analysis? So you will find three measures. The first one is called sum of incisors, wherein you measure or determine the sum of mesiodistal widths of the four maxillary incisors. The second is the measured premolar value, width of the arch in the premolar region from the distal pit of upper first premolar to the distal pit of the opposite first premolar, and measured molar value, wherein you will find the width of the arch in the molar region from the mesial pit of the upper first molar to the mesial pit of the opposite first molar. So then what is the inference? Here there is something known as calculated premolar value, or the ideal arch width in the premolar region. There is a formula for CPV, that is calculated premolar value. That is, you will use the value you have found out by measuring the four incisors, that is SI, and you will multiply it by 100 and then divide it by 80. So that will give you CPV. The same way there is CMV, that is the calculated molar value, and for CMV it is SI times 100 divided by 64, which will give you CMV. So what is the inference? If CPV or CMV is more than PMV or MMV, that is, if the calculated value is more than the measured value, then it indicates the need for expansion. So if the calculated value is more than the measured value of the premolar and the molar region, it indicates the need for expansion. So what are some of the limitations of Pont's analysis? If you have missing maxillary laterals, then you're unable to calculate SI. if there are peg-shaped laterals. Yet again, you're unable to calculate SI. So none of the other values can be derived from this. And the analysis was done from the cast of French population. So it is questionable as to how to generalize it to other ethnicities or other people from other backgrounds. And it does not take into consideration the skeletal malrelationships you see in the craniofacial region. The next analysis we will be discussing about is LINDER-HARTH analysis. So LINDER-HARTH analysis proposed an analysis which is very similar to that of PONT'S analysis. It's just that the formula used to determine the calculated premolar value or the molar value is a little different, and the value is different. There we used 80 and 64, whereas we're going to use 85 and 65. So that's the only difference between PONT'S and LINDER-HARTH analysis. Okay, the next analysis is Korkhaus analysis. This analysis is similar to PONT'S analysis. However, there is a difference between this and PONT'S in that here Lindenhart's formula is used to determine the ideal width in the premolar and the molar regions, that is CPV and CMV are based on Lindenhart's formula and not on PONT'S formula. And also, in addition, this analysis utilizes a perpendicular distance between the midpoint of the central incisors and a midpoint of the interpremolar distance. You can see that measure as A on the image. So what do you infer from Korkhaus analysis? So basically, it is the distance between 1 and 2. 2 is the midpoint on the interpremolar distance, whereas 1 is the midpoint between the two central incisors. So this distance between 1 and 2 will increase if there is proclination of upper anteriors. If the distance is less, or if the teeth are retroclined, you will see the distance to be shorter. Okay, now we have reached Bolton analysis. This is an important analysis, so you will try to understand it with much more keenness. Anyway, so Bolton analysis will help you to determine the disproportion between the size of the mandibular and maxillary teeth in well-aligned upper and lower arches with normal overjet and overbite. There will definitely be a relationship or a definite proportionality of tooth size between the two arches. So if the proportionality is met, the maxillary dentition fits well with the mandibular teeth. All right. At the same time, the presence of disproportionately sized teeth in either of the arches can make it difficult for obtaining a good alignment or an ideal overjet, ideal overbite, or even normal class 1 molar relationship. So what is the procedure of Bolton's analysis? So step 1 will be to find the sum of maxillary 12 and the mandibular 12. So you'll use your vernier calipers or you'll use your dividers to measure the mesiodistal width of the teeth mesial to the maxillary or mandibular second permanent molars. That is, you will start from 6 onwards. Okay, and then once you have calculated each of the individual widths, you will sum them up. Then the step 1B would be to find the mesiodistal width of all the teeth mesial to the maxillary or mandibular first permanent premolars. That is the sum of maxillary 6 or the mandibular 6. This is the anterior teeth, right? That is from 5 to 5. Once you have measured and calculated, you will sum them up and you will keep the numbers aside. So the next step is to determine overall ratio. So how are you going to do that? So you'll use the formula wherein you will take the value which is the sum of mandibular 12 and divide it by the value of sum of maxillary 12 and then multiply it by 100. So whatever the number you get, if it is less than 91.3, will indicate maxillary tooth material excess. If the number you've got is more than 91.3%, then it will indicate that there is mandibular tooth material excess. In Bolton analysis, you can further determine the maxillary tooth material excess, which you just calculated using the overall ratio formula. So for this, you will use the sum of maxillary 12 minus sum of mandibular 12 into 100 divided by 91.3. If you want to calculate the same for the mandibular tooth, you will switch the numbers, and instead you will use sum of mandibular 12 minus sum of maxillary 12 times 100 by 91.3. Step 3 of Bolton's analysis will involve the determination of anterior tooth ratio. So you found out overall tooth ratio. Now here you're going to find out anterior tooth ratio. So what is the formula used? So sum of mandibular 6 by sum of maxillary 6 times 100. So whatever the number you have got, if it is less than 77.2%, it will indicate that there is maxillary tooth material excess. If on the other hand, the number you've got is more than 77.2%, then it will indicate that the mandibular tooth material is excess. So again, you can further determine maxillary tooth material excess by the below formula, which is sum of maxillary 6 minus sum of mandibular 6 times 100 divided by that value, which is 77.2. For mandibular tooth material excess, you will change or you will switch places, and then you will calculate the sum of mandibular 6 minus sum of maxillary 6 times 77.2 divided by 100. So these values, you can keep them aside and use them to understand which tooth material is excess for 6 teeth, that is anterior, and also for 12 teeth. Okay, we've now reached the second leg of model analysis, which is the mixed dentition analysis. Basically, what is the purpose of performing a mixed dentition analysis? So here it will help you in evaluating the amount of space available in the arch for the permanent teeth to fit in. It will also help you to assess the mesiodistal widths of unerupted permanent canines, first and second premolars. These are basically done using something called as prediction tables, or you can perform them on a cast or on a radiograph and compare them with the values on a prediction table. Um, so there are several mixed dentition analysis you can perform. So we shall go into the details in the next few slides. So here is a brief um, mention of which are all the different analysis you would be performing under mixed dentition analysis. Basically, Moyer's analysis, Korkhaus, Hickson and Oldfather, Stanley and Kerber, that is based on the prediction table. Based on radiograph will be Nance mixed dentition analysis, Korkhaus, Hickson and Oldfather, whereas based on regression equation will be Tanaka and Johnston. So basically, I've highlighted 3 here. So if you're able to remember and understand these 3, it would suffice. Moyer's analysis. So what you're going to do in Moyer's analysis is there is a probability chart provided by Moyer's. So you will analyze and measure space required and space available from a dental cast. And then once you have these distances, you will predict the mesiodistal width of unerupted upper and lower canines from this probability chart, which is give or take 75% accurate. So how you're going to do this space required, you already know from the previous analysis how you performed the space required. And at the same time, space available, again, you have performed it in other analysis. However, here you will use um, the distance between the distal surface of the permanent lateral incisors and the mesial surface of permanent first molar. Distal surface of permanent lateral incisors to mesial surface of permanent first molar. So once you have this distance, you're able to determine the amount of space required for proper alignment of incisors. So once you have done that, whatever space is left behind will give you the amount of space availability. So all these work in conjunction with the probability charts. So whatever the mesiodistal widths you have measured, you will do a comparison with the probability chart for you to understand or estimate or predict, okay, the mesiodistal widths of unerupted upper and lower canines and premolars based on the probability chart. So the probability chart plays a very important role here. Now Tanaka and Johnston analysis. So basically this will help you to predict the width of unerupted canine and premolar using the width of lower incisors. And so it has a good accuracy in its prediction and is based on a formula with 75% prediction values. So how do you do this is you will calculate the sum of widths of mandibular permanent incisors and then divide by 2. So whatever number you have for lower arch, you will add 10.5 millimeters, and for the upper arch you will add 11 millimeters to obtain the total estimated width of the canines and premolars. So the value you've calculated plus 10.5 millimeters will give you the total width of canines and premolars in the lower arch, whereas adding 11 millimeters will give you the total estimated widths of the canines and premolars in the upper arch. The next analysis is Nance mixed dentition analysis. So this is similar to arch perimeter analysis of the permanent dentition. So what you need is dental cast, a Bowley gauge, a millimeter ruler, excuse me, and a periapical radiograph. So what are the advantages of this particular analysis? It has minimal errors, it can be performed with reliability, and allows analysis of both maxillary and mandibular arches. However, it has one or two limitations, the first one being time consuming, and a radiograph is needed. So if you have a radiograph and if you don't mind the time, you can perform a Nance mixed dentition analysis. So here again, space available and space required. These are the two measures you have to find out. So you will use a brass wire as an arch perimeter analysis and measure the arch perimeter from the mesial surface of the first permanent molar to the mesial surface of the first permanent molar on the other side. That is from one permanent molar that is in the right quadrant to the left quadrant, and compare the space required and space available to arrive at the arch length discrepancy as you did in arch perimeter analysis. So once you've done uh, the measurement of space available or availability of space, then you can do the amount of space required, which is by measuring the mesiodistal width of the erupted permanent teeth and you can also measure the width of each unerupted tooth, cuspids and bicuspids from an IOPA. The total mesiodistal width of all the teeth in each quadrant will indicate space required to accommodate the permanent teeth. So basically, how much space is required minus how much space is available will give you the discrepancy. So here you can see images which will help you better understand Nance analysis. So image A is the measurement of mesiodistal widths of permanent incisors on a study model. So image B is the measurement of the unerupted canines and premolars on a radiograph, and C is the measurement of arch perimeter on the study model. So basically, the amount of space available is from 6 to 6. For that, you will have to calculate A, which is the mesiodistal width of the permanent incisors, plus B, that is the mesiodistal width of the unerupted canines and premolars. And then you add these spaces to give you the total amount of space available. Hope that's clear. So now coming to the last method, which is the radiographic method. So basically this uses a radiograph to determine or predict the width of the unerupted teeth using a formula uh, that is y1 equals x1 times y2 divided by x2, where y1 is the width of the unerupted tooth whose measurement is to be determined, whereas y2 is the width of the unerupted tooth on the radiograph. So y1 and y2 are the widths of unerupted teeth. X1 and X2 are the widths of erupted teeth. So X1 is the width of tooth that is erupted on the cast. So and X2 is the width of the tooth that is erupted, that is measured on the radiograph. So here X1 will be the measurement performed on a cast, whereas X2 is the measurement performed on the radiograph. So using the formula will help you predict the width of unerupted teeth. So mixed dentition analysis will form an integral part of orthodontic diagnosis as you're able to um, understand if an individual requires serial extraction, any kind of space maintenance, arch expansion, or you want to take a passive route and observe with periodic recall. So mixed dentition analysis will help you to perform all these. So though we used casts and radiographs and we did conventional analysis, however, with the current technology, you are able to do an analysis using the software. So this is just a screenshot of one of the software which is currently being used by orthodontists or in educational institutions. So here you're able to do several of the analysis we've discussed in this lecture on specialized software like this. So hope you will get a chance to work your way through this sometime. And also you can find model analysis apps on your mobile devices for you to perform model analysis at the slide of your fingertips. So basically, these are all the advances in orthodontics with the use of current technology. So I would encourage you to try these out on your devices whenever you have some free time. So you can just find them on the Play Store and you can install them and use your own imaginative measures or for the mesodistal diameters, and then work your way through the apps and um, understand how these apps work, and you'll be able to better understand all the conventional methods we have just utilized, because here all the formula and the formulae are already built in. So by just entering these values, it's going to give you the output. But I would encourage you to remember the formula from the viewpoint of your examination. For routine examination and diagnosis, you might definitely use this, but however, be cautious of how to interpret your results. You have to always interpret the results from a variety of diagnostic aids and not just one. All right. So with that, we've come to the last slide of today's presentation. Um, so today we've been able to cover uh, uh, the analysis used to assess the need for extraction, analysis used to assess the need for arch expansion, and also mixed dentition analysis. However, I would encourage you to install the model analysis application on your phone and try out the various features it has to offer, so that you have a better understanding of what to expect by changing different measurements and seeing the resultant output. So until the next time, stay safe and stay home. Good luck, and thanks for listening to the lecture. Bye bye.